Okay, folks, section 5.5, the differences of two squares. Now I want you to have your thinking caps on here, okay? Perfect squares are numbers that can be written in the form of x squared. All right, so for example, 9 equals 3 squared. I can write 9 as 3 squared, so that means that 9 is a perfect square. Or 25 equals 5 squared. Okay, that means that 25 is a perfect square. Look at this one over here. Okay, x to the fourth is equal to x squared squared. All right, so that x to the fourth is a perfect square because I can write it as something squared. All right, now let's go down here and let's look at this part. This is a difference of two squares. I'm going to circle it in black here. 9x squared minus 16 is a difference of two squares. And I've got some arrows here pointing, okay? 9x squared is a perfect square. All right, I can write it as 3x squared. 3x times 3x gives me 9x squared. So 9x squared is a perfect square. 16 is a perfect square, right? I can write it as 4 squared. And you know what? I should have. There we go. All right. Now, this is also a difference between two perfect squares. All right. Now, this is a special kind of binomial that we're going to see a lot of. So we need to be familiar with it. We need to look at it and go, oh, that's a difference of two squares. All right. So that we'll know what we can do with it. All right. Now let's move down to this next part. All right. Now, when we factor, and remember, factoring is unmultiplying. When we factor a difference of two squares, we get the following pattern. All right, now I'm going to use the example that we had above, 9x squared minus 16. Okay? Now, when we factor it, that means writing it as two things multiplied together. We're going to get two binomials, which you're going to see right here. And the first term, 3x, is the square root of this. The second number is the square root of this. And we get the same thing in the second binomial, right? 3x and 4. The only difference between them is that this one is minus and that one's plus. We always make one minus and one plus. So 9x squared minus 16 is equal to 3x minus 4 times 3x plus 4. Square root of the first term minus the square root of the second term times the square root of the first term plus the square root of the second term. All right? We always factor a difference of two squares that way. Always that way. When do we do it, Mr. C? Always. That's the way we factor it. Now let's go down here and look at this. Okay? You also need to see that when two binomials have the same numbers and the only difference is the sign between them, the product is the difference of two squares. So let's look at this, right? We're starting with 2x minus 7 and 2x plus 7, all right? Now the numbers are the same. We've got 2x's and we've got 7's. The only difference between them is the minus and the plus, okay? Now, I need to just know that when I see this, I'm going to get the difference of two squares. I square the first term, I square the second term, and I'm going to stick a negative between them. All right? Now, you can multiply it out. All right? So we've got 2x times 2x gives us, oh, are you serious? I did that? Look at that. Look at that. It happens. Is 4x squared. And then 2x times 7 is plus 14x. Then I've got negative 7 times 2x, and I get negative 14x. Do you see that middle term, the linear term? I'm always going to get a positive one and a negative one, and they're always going to cancel out. And then I'm going to have negative 7 times positive 7. That gives me negative 49. So these two linear terms cancel out, and they leave me with 4x squared minus 49, which is a difference of two squares. Okay? You can go back and look at the one before. 3x minus 4 and 3x plus 4. If we multiply that out, we're going to get the square of the first term, 9x squared, minus the square of the second term, 4, which gives us 16. Okay? Now, that's what we're doing today.